Now let's start coding the circuit breaker. So I've created a project and this is a blank project. I have deleted all the flows because we don't need them. I have modified the pom.xml and made the packaging as Mule extension. There are no dependencies as such, but later on as we uh, create logic, we'll add the dependency. We'll need Hazelcast dependency for that, so we'll add it later on. But for now, let's get started. The only thing that I have added extra is the parent because that's needed for the custom connector. If you're not sure what is this for, you should check out my previous videos on creating custom connectors. So we'll first start by creating a class which would be called as an extension. So that is where everything starts. So in the extension package, I have already created it. I'll just create a class now. I'll name it as CB extension and let's just create this class. Hit on finish. Okay, so the class is ready. Now we'll have to reserve a namespace. So I'll add XML prefix equals CB. So everything will be CB colon for this connector when we use it in the flow. So I'll just import this. Okay, so it has imported from the Mule runtime extension, the XML prefix. Now I need to give an extension annotation and let's name this as circuit breaker. In case if you're not getting what does all this mean, you can just go on my previous videos of custom connector and you'll understand what's the meaning of at XML annotation and what is the meaning of extension annotation. Once we have all of this, let's create a configuration. So configuration will be used to configure the Hazelcast cluster. Just add configuration annotation and give the class. So I don't have the class yet, but I can create the class now. So what I'll do is I'll create a new package and name it as um, package and name it as configuration. So let me just copy it from here and let's create a new package and I'll name it as configuration and let's hit finish. Now this configuration will be used to create the Hazelcast cluster. So let's just create a class named as configuration service. Configuration service. And this class will in turn use a parameter group. So what we'll do is we'll create a parameter group over here and name it as cbconfig parameters. So I'll create cbconfig parameters. Okay, and let's hit finish. So idea of this class is that we need to have configuration parameters using which we can configure the Hazelcast cluster. So what we can do is I'll add three parameters to it and I'll explain what I'm trying to do over here. So first will be a string which will take IP addresses. So I'll name it as members IPs. Then the other one is private string host IP and then the cluster port. So these are the three parameters that I would need. Now, what is the meaning of these three parameters? The first parameter will be comma separated values. So whenever we deploy an application that will have circuit breaker, it should have the list of IPs that should form a cluster. For example, if we see this here, the CB demo app has two instances in two different servers, right? So for this, both of them to be in sync, for Hazelcast to be in sync, it should know about the IPs of the other machine, right? Only then it can form a cluster using Hazelcast, right? So for that to happen, we need to inform Hazelcast that these are the IPs which should form a cluster and they should keep all the data in sync between each other. So that is where we are going to use this members IP. So this will be a comma separated value and will create a cluster out of those IPs. Host IP is the IP of the machine on which the application is deployed. So in case of CB demo app deployed on server 1, it will have this host IP 192.168.1.101, and in case if it's on node 2, it will have that ID. So the person who configures this circuit breaker in his code has to provide these details. So that's the host IP. And then we have the cluster port. So cluster port is the port that Hazelcast would use. So any web app, right? It has a port accessible. Even if you configure a listener, you have to provide a port. So same is the case for Hazelcast cluster. You'll have to provide a port to it. And in case if you do not, Hazelcast automatically binds the 5701 port uh, for for its operations. So I hope you understood what all these three parameters mean. So what I'll do is I'll quickly create setters and getters, and let's generate, yeah, select all, and let's generate. Okay, so I have the setters and getters created. Now what I'll do is let's decorate this with at parameter so that this gets used as a parameter. Now I need to import this from Mule runtime. So this is a parameter. This is optional. If you do not want to join any cluster, if it's single instance, then it's fine. So no need to specify this value. And let's add a display name. In case if the member IPs are not specified, it won't join any cluster. It would be considered as a standalone deployment, wherein there are no uh, multiple copies of the application deployed on different servers. And a display name, let's just give it a meaningful name, members IP addresses address, and do a control shift O for auto import. Okay, it's not display, it's display name, and let's organize the imports. Okay, and for ease of understanding, I'll add a summary, and in summary I can give something like comma separated. I'm specifically mentioning because I'll split by the comma field. So it should be comma separated IP addresses. Address of members who would join the cluster. All right. And let's organize the import. Okay. Now same thing. Let's copy all of this for host IP and let's just change the display name. It should be host IP address. Host IP address, and let's change the summary. So the summary will come up when you just hover around that field and it will show a tooltip mentioning what is required in it. So let's just give something meaningful, IP address of the system that will host this connector. Okay, then we have the cluster port, and this let's just copy this same thing and just change the display name and the summary. So display name will have it as cluster port. So this is the port that will be used by Hazelcast. So if it's not specified, now look at it, everything is optional. So if it's not specified, it will take the default. Hazelcast will take the default as 7001. Okay, let's just remove this summary and add something meaningful. Port that will be used by Hazelcast. Okay, and so we have the summary created for this field as well. Now let's add some default values. So I'm speaking about default values. So Hazelcast will take it automatically, but from our end, we can also add some default values. So if member IP addresses are not there, it's fine. Like the user does not want a cluster to be formed. But if host IP address is not there, what should be done? We can add a default value to it using the optional annotation, and it should be localhost. So what we can do is we can use 0.0.0.0. That should be fine. So that's the localhost IP, or we can also use loopback address 127.0. This both of them makes sense. So this is the IP. This is the loopback address that refers to the same host on which the application is hosted, and cluster port. So let's give a default value as um, I'll give it as 5701. So let's just keep this defaults. And yeah, we are pretty much done with this. Now, the idea is to use this parameters in the configuration service. Okay, so what we can do over here is we'll just use this. Okay, and add a parameter group and name it as private CB config parameters. Okay, and this should hold the config. And let us decorate this with parameter group and give the name as cluster config. So when we configure the connector and we create a config for that connector, this can be seen as cluster config. And this cluster config will have all these values that the user will have to populate. So that's done. Now we'll have to implement logic over here, but as of now, we'll leave it as is. We do not want to add the logic. We'll add that complexity later on. We just want to get a structure ready in this case. I mean, we just want to create the close and open root. So for that, we are doing all this. So let's decorate this with operations annotation, and the operations class we will be creating is CBOperations dot class. So we don't have the class yet, but we'll create one. So let's quickly create this class. So I'll create a package which will be in this package. I'll name it as internal. So dot internal. There's a typo. Okay. And in this package, let's create the operations class. So it's CB operations. Okay, hit finish. So we have a class ready. Now this is the operations class which we have defined over here. So let's do Control Shift O. So the class is ready and the compile time errors have gone away. So if I click over here, so any method, any public method defined over here will become a connector. So first we want to create a root, and the roots that we discussed was main root and fallback root. So for that to happen, what we have to do is we'll create another package for hosting the root classes. So let's just create, let me just copy this again and create the root package. New package dot roots, and I'll create two classes for each root. I mean one class for each root. So there will be two classes. So one is the fallback root. Let's hit finish. And the other one is main root. Okay. Now for this root to actually work, we have to extends root, and this root will come from Mule runtime. So let's organize the imports, and we have two options. So we have to use this Mule runtime extension API runtime root. So let's hit finish. Okay, it's imported and we need not do anything. We just need to use this as an argument in the operations class methods. Same over here. Let me again extend root, Control Shift O to organize imports, and let's click on the first one. So we have two roots ready, fallback root and the main root. Now what we want to do is we'll use this root. So let's go back to operations. Now in operations, we'll have a few parameters to be defined. For example, when we create the circuit breaker connector, we would want to give a unique ID, because there will be a replicated map created and each app will have its own ID, and that ID will represent a particular application and the value will be the state. So we need to get an ID for the circuit breaker. So we'll first create a public method, public void, because this won't return anything. Instead, it will just route the data to the particular root, which is open, or I mean fallback or main root. So circuit breaker, let's name this method, and this method will take some arguments. But before doing that, let's decorate this. Now I'll add a display name to it. So display name circuit breaker, and even if I don't give a display name, it will by default take this. So it will just make C as uppercase, space, and breaker. So but let's just give a name to it, circuit breaker. All right, now this argument will have all the details, what all we want. So we want the person who is using the circuit breaker needs to add an ID. So what we can do is we'll create a string argument, which is circuit breaker ID. All right. And we again need to decorate this. So since this is method argument, it needs to be separated by comma. But let's first decorate this, and we'll keep this as optional. So in case if someone doesn't add this, I mean, this should be unique. So in case if someone doesn't add it, we'll have a default value, which will be a data view expression. So that should be app.name. So app.name will give the name of the application in case if it's not added. Okay, then we can optionally have a summary to let the user know what needs to be added over here. So let's just add a summary, and this summary will have Let me just add unique ID for the circuit breaker. So it should be unique, right? So it should be unique for every application, because if it's not unique, it might trip the status of some other application, right? So it should be unique for every application to avoid unexpected behavior. Behavior. All right. So let's do Control Shift O to import the summary. Now, optionally, we can add a display name. So let's just add a display name over here, and so this will be displayed in the UI when we are configuring. So what I'll name it as circuit breakers. Just add ID to it. That makes sense. Okay. Then we have the next argument. So the next argument will be threshold percentage. Now threshold percentage will define what is the error percentage you want. For example, 100, 50. So threshold percentage means the number of errors divided by the number of operations. So if this ratio into 100, which will give us a percentage, if that percentage is equal to or greater than the threshold percentage, the circuit breaker will trip, right? So that's the idea. So let's just add string threshold percentage. Okay, and I'll copy and paste the same thing. Just modify this. So default value which I am looking to give is, I'll give it as 100. Summary, let's just give something meaningful. So it's like threshold percentage of errors after which the circuit will trip. Okay, so that's done. And display name, let's change it to threshold percentage. All right. Now the next thing is the threshold period. Now for how long do we want to monitor? For example, the first error, okay, the first error based on uh, will give an expression also for what should be counted as an error. We can count every error as an error, but circuit breaker should not count every error as an error, right? If there are some connectivity issues, those should be counted as an error, right? So what we'll add a threshold period. So for example, if we defined connectivity as the error to be counted, so from what point? For example, the connectivity error started coming at 2 p.m. The first connectivity error started coming at 2 p.m. So at 2 p.m., starting from 2 p.m., the circuit breaker will start the window period for tripping. So suppose the threshold percentage is 100 and the time period is 10 minutes. So in case in 10 minutes, if there is 100% errors, okay, so like in that 10 period window, there were 10 transactions and all of the 10 transactions failed due to connectivity errors, then the circuit breaker should trip. So we'll add that parameter, which is the threshold period. So I'll add string threshold period. Okay, so and let's just copy the same thing for it. I'll just modify it. Okay, so threshold period, and it should be default value. So default value, so this will be ISO 8601 date format, the way we use in data view. For example, PT, so period time is 1 minute. This is the default value that I want to add. So anything we can add based on this this format, the ISO 8601 format. So I'll just give a summary so that the user knows what to add. So ISO 8601 duration format. And what does this field do is that it determines the duration for which the duration for which the errors should be monitored. Okay, our short description should be good enough. And then the display name. So this display name should be threshold period. Okay, so until here we are good. Now let's add another field which is the open duration. So once the circuit breaker trips, it opens up, then there should be a certain window for which it should be opened. For example, 5 minutes, 10 minutes. So that is the recovery period which we are giving to the other API so that it recovers and will then start sending messages again. And the circuit breaker will switch its state back to normal, which is the main route in this case. So let's just add that field, which is string open duration. So this is all in string, then we'll parse the string into duration. So this is open duration. Let me just copy paste the same. Okay. And now let's change everything. So optional field. So this is again optional. So if it's not added, it will take this default as 1 minute. Summary remains the same, at least the part before comma. And we'll just change this part and make it as what to add. It determines the duration for which the circuit remains open, and then it will go back to the closed state, and this will be open duration. Okay, so this is done. Now another field is we want to count errors, right? So there should be some criteria. It should not happen that we count every error as an error. So some error could be coding defects, like for example, mule expression errors, or there could be some business errors. So that doesn't mean we should trip the circuit for those errors, right? So we should give the user flexibility to decide or to tell what is an error, right? So for that, we'll give an expression option to specify error, and we'll use a parameter resolver. Now, the reason why I'm using parameter resolver is that if we take it as a string, uh, then it's difficult to resolve that value. Or if I take it as a typed value, data view will automatically resolve that value and resolve that expression and give it to me as a value. I don't want to eagerly resolve the value. I want to resolve this value only when any of the route is successfully or executed with errors. Only then I want to resolve this value. So I'm using this parameter resolver. So it will just give me a string format of the DW expression and won't evaluate that expression. So I'm basically deferring the evaluation because I don't want to eagerly evaluate the expression. So I cannot use string over here. I cannot use typed value. I'll just use a parameter resolver so that I can resolve this expression on demand. I'll give this as object, so it can be anything, and I'll give it as expression. To make more sense, let me just add error expression. So this makes more sense, right? So this is the error expression, and let's do Control Shift O to organize the imports, and it's imported. So what did it import? Yeah, it imported parameter resolver. Okay, now same thing. Let's give some decorations to it. and optional value. Okay, so the default value which I would want to have is something like error should uh, be not be equal to null. So in case if there's error, the error object will be populated, right? So if it's not null, I mean, by default, it will count every error. But if you specify something, that will override this particular expression. So let me just give a default expression output application Java and error not equals null. So this will be the default expression that will be present if it's not configured. And the summary, so what I'll write is DW expression to specify the error. Uh, the expression and must evaluate to true to consider an error trip the circuit breaker. Okay, let's add this. So we have the error expression with us now. So we are pretty much having all the parameters that are required for a circuit breaker. So one is the ID, the other one is threshold percentage, and this threshold percentage will require threshold period. And then once it trips, then there should be an open duration. And finally, we have the expression that should be used to count errors. Consider means what errors should be counted as error for the circuit breaker to trip. Okay, so now we want to make this as a root. So we want two roots. One is the fallback and one is the main. So main is the happy path. So we'll have to add those two root as an argument to this method. So what I'll do is I'll just add the first is the main root. So this will help me to create two different root, main root and then fallback root. Okay, it's there's a missing comma, that's why it's giving expression error. And let me just organize the imports. Okay, so it has imported the classes, and let's just give this a display name if it allows. Okay, it's allowing me to add display name, so this should be main root and the other one should be fallback root. So it's fallback root. All right, so we now have two different roots and the parameters that we need for this circuit breaker to trip. And then one more thing that we need to add is the router completion callback. So what usually happens is in case of any route, so there is a callback. So this route thread is it's non-blocking, so it waits for a callback. So whenever whatever if whatever operations are present in any route, if those are completed, so consider this route as a scope. So if there are 10 operations, once the chain of operations, so these are chain. So the chain of operations, once those are completed, then the runtime will automatically send a callback to this scope. And then the scope has to work according to the callback. So callback means that, okay, boss, all the operations inside the scopes are completed. Now you can proceed further. So that is what callback means. So we need to provide a callback and the runtime will automatically give this callback once the chain of processors have completed their task. So router completion callback, and name this as callback. So this is an interface and it's already implemented by the Mule runtime, so we need not worry about its implementation. So these are the basic requirements for the circuit breaker. So now to avoid any confusion, let me just repeat again. This parameters will only be used for the circuit breaker for tripping. So to change the state of the circuit breaker to either open, error, or closed state. But the configuration that we have specified over here, we also specified few parameters over here. These are for the Hazelcast cluster. So there are two different things. Okay, so now here going back to the extension, now we have created operations. Now in operations, we are not going to do anything yet. We'll add the logic later on. We are just creating the structure of the connector so that we understand what's going on. And later on, slowly, we will improve this logic and add the actual logic over here. So now back to the extension, we'll add a configuration. So we have the configuration ready and that configuration has a linked operation to it, right? So we can add CB. So we created a configuration service. So let's configuration. Why is it not showing? Okay, it's named as configuration service. So let me quickly rename this. What's that? CB configuration service. Okay, let me just refactor this. Refactor, rename CB. Okay. So it should get refactored in a moment. Just wait for it. Okay, let's hit finish. All right, so okay, and let's mention the class. Okay, so everything is imported and we are able to have this configurations. Now, I think we are pretty much ready. So this is the extension class. We reserved a namespace. We have the extension named, and in configuration, we have this configuration service, which is referring to an operations, and it also takes config parameters, and we have all the setters and getters. So I think this is enough to at least get a structure of the circuit breaker. So we want to realize how it looks, right? So let's try to build this project. So let me just go to this connector folder. I'll install this connector. So let me just install skip tests. So the connector has been installed successfully. Let's go back to the Anypoint Studio and try to import this into some project. So let's create a new project. So what was the name that I decided? CB demo app. So file new CB demo app. Okay, let me hit finish. And let's quickly import this. So I'll add dependencies, and in dependency I need to add, okay, so this connector, let me go back Um, all right, now I should add it over here in the dependencies section. We add another dependency. Okay, so the group ID is com.resiliency.connectors, artifact ID circuit breaker connector, and I'll need to add this classifier as well as Mule plugin. So this should give us the connector. So let me just save it and it should come up. Okay, so we have the connector with us. Now let's see what all operations do we have. Now back in the flow, we are able to see the circuit breaker module in Mule palette, and let's drag and drop this operation. Now we see two routes, main route and the fallback route, and the general properties have been populated. Circuit breaker ID, if I hover over it, I am able to see the tooltip, I mean the summary that we added, and it's populated with the default values. Same as for threshold percentage, threshold period, open duration, and open duration. Okay, so here's a mistake that we made. Instead of error expression, we have made it as open duration. This is possibly a copy paste error. So let's go back to CB operation. And if we observe its open duration on error expression. So we need to update this and reinstall it. So we'll do that later on, but it's just that there's some display name issue. We can correct it later on. So this values are enough for us to implement the logic for the circuit breaker to carry on its activity. The other thing which we coded was for the configuration. So let's go to the global element, and here is the circuit breaker config that I've already added. So if we go click on it, it's already defined. The default values are defined. It's like the loopback address that we added. It's present over here, and the cluster port, and all the tooltips are coming as expected. One point to notice over here is, as opposed to the normal requester component or a listener component. So these are operations, and these operations can refer to configuration. But the routes or the scopes cannot refer any configuration. That's because they are designed in that way. A, a route or a custom scope or any scope for that matter is supposed to play around with the message. It's supposed to have a chain of operation. It never does any task of calling any other systems. So it makes sense not to have the configuration. But the Hazel class cluster that we are going to use will definitely need some configuration, and that's the reason we created the circuit breaker config. Now we would need to ensure that this circuit breaker config has been configured, and in case if it is not, we would not be able to initialize the Hazelcast cluster, and then it's of no use, right? So in the logic, we'll have to implement a condition that without implementing this element, the flow or the application should not get deployed in the first place. And we'll see that in the next couple of videos. So we are now ready with the basic structure of the circuit breaker connector. The only thing is to bring it to life by adding the algorithm to the connector. So I hope until now you would have got a fair idea of what we are trying to achieve and might have found the video useful. Thanks for watching.